Okay. Today I want just to start with basic fundamentals, and because if we don't know fundamentals, we cannot proceed further. We cannot capture or catch the further big idea behind it. So first we need to know what is analog and digital. What is the meaning for this word? So we need to know that. Uh, I used to take impact sessions. If we want to uh, join, if you want throw any questions, you can throw in the screen. So I will go with the explanation of this analog. I want to open the screen. Oh. So if I ask student what is the number after, what is the number after 5? So he would say 6. Number after 5 is 6. And if I ask what is after 6, he will say 7. But we also know that after 5, it is not 6, it is 5 point maybe 01 or 5.001, or it can be 5 point infinite number of zeros. Hello, can you hear me? Hello. ಇದು ಮಾತನು bro. Okay, sorry for my uh, bad volume of microphone. This is not ringing. Okay, I think everyone can hear me. So I will start analog and digital. As I said before, if I ask student what is the number after 5 or number after 6 or number after 7, they will tell after 5 it's 6 or after 6 it's 7. Okay, then it is true, but it is also true. What is can be 5.01 or 5.0 2 or 5.00001 or 5.00001 can be a mil. Sorry for the bad volume. Just wait for technical issues. Hello, hello. கேக்குதா? Hello. Okay. Between 5 and 6, we have infinite number of numbers. So this also true, and this is also true. So if we consider 6 as the next or after number of 5, it is digital. Okay. If it is, we are considering this after 5, we have we may have continuous number of numbers, that is infinite numbers, then it is called analog. Okay, so am I clear with that? So after 5, we take it as 6, it is called digital. It is digital is a discrete set of values. So digital is discrete set of values. Analog is continuous set of values.
So now let's deep dive into next topic. So why we need to learn digital and why we need to learn analog? Okay, because our microcontrollers takes data from the outer environment as analog signals, but our microcontroller is a digital microcontroller. It doesn't know any analog. It doesn't recognize any analog values. So we need to learn both what is digital and what is analog. Okay. Then some of my students ask me why we call this speedometer in our bike. We call it as digital odometer, right? Why we call it as digital odometer? Because if I am traveling at a speed of 55 kilometer per hour, after 55 it will not go to 55.5 or 55.6. It will never show that. After 55 it will show us 56 or 57 or 58. So it is a discrete set of values. Got it? So if it is a discrete set of values, it is showing, our odometer is showing a discrete set of values. So we call it as digital odometer. Got it? So our I can call my bike's odometer as digital odometer because after 55 it shows 56 and after 56 it shows 57. It's a discrete set of values. What is discrete? What is discrete? If we go to the online and we search for the meaning for discrete, it is showing us individually separate and distinct. So we have a separate distinct values. So it is called a discrete set of values, and we call it as digital values or digital values. Okay. Then what is analog? Analog is a continuous set of values. So in my father's bike, we have a odometer as with a needle. Okay. So if he is traveling approximately at a speed of 46 or 45, so the needle will be between 45 and 50. Okay, got it. If I ask some student or ask my father, he may tell what now at what value that needle is pointing. He may tell it. He may tell some values between 46 and 50. It may be 47 or he may tell us 47. If he ask if I ask my brother, he may tell it as 48 or 49 or 46.5 or 45.5. So it can be any values between 46 and 50. So it is a continuous set of values. It is not a discrete values. It is not a individually separate values. It can be anything. So it is called analog meter. Got it? So okay. So we got the basic idea of what is digital and analog and why we need to study about digital and analog. Okay. So next we need to learn about from this basic idea we will keep on build the ideas and we will know what we are going to do and how we should control the microcontroller. Next we need to learn what is binary language. Okay. What is binary language? Usually people say it is zeros and ones. And what is digital? People used to say zeros and ones are digital. Why it is called as digital? Why we call this zeros and ones, which is computer language, we call it as digital? Because there is nothing between 0 and 1. There is nothing between 0 and 1. After 0 it is 1 or after apart from 1 it is 0. Between 0 and 1 there is no 0.5. There is no 0.6. There is no nothing like that. So it is a discrete set of value. 0 and 1 is a discrete set of value. So we call it as a digital. And our computer knows, our microprocessor understands only zeros and ones. Am I right? Okay. So we call zeros and ones as digital. It is right according to what we studied before. So we can call these zeros and ones as digital. Next, we will think why, how can a 0 and 1 can be a language for the computer? How this computer doing many things with this 0 and 1? How it is doing it? So let's take an example and let's take an example. I heard a story. I heard a story of a king. Consider this as a king. This fellow as the king. This fellow king, he is afraid of the enemy who is going to take who is going to wage war on his empire. So in this king empire, there is a lighthouse. Okay, this is the lighthouse, and we have a lighthouse watchman, or keeper, lighthouse keeper. This king spoke to this watchman, and he told this watchman, if any enemies invades for a war, if any enemies wage for a war, we just turn on this light. Just turn on this light to indicate. Just turn on the light to indicate that enemy is waging war. If it is not, the light is not lit, there is no war, there is no enemy waging the war towards us. So this light, if it is on, this light, if it is on, it is telling a message that there is a war, there is waging, that enemy is waging war. If it is off, then it is conveying a message there is no war. So this either on or off. Either if it is on, we may consider it as 1. If it is off, and we may consider it as 0. Okay. So if it is on, the enemy is waging war. If it is off, there is no war. So this on and off is conveying a message, but it's too short for a language. Okay, this on and off cannot form a language, because in English we have 26 alphabets, in Tamil we have 247 alphabets, and many languages we have a many number of alphabets. How can a two alphabet 0 and 1 can be a language? Okay, then the enemy waged war, but okay. The enemy waged war, but on the day, the king cannot see from which direction the enemy is coming from. So in that lighthouse, they kept another two lights. Then they devised a plan. If the enemy is coming from the north, you just turn on two lights. If the enemy is coming from the south, you don't turn on the both light, just turn on this war light. Okay, these two are direction lights. If the enemy is coming from the east, just turn on the left light and turn off the right light. If enemy is coming from the east west, then turn on the right light and turn off the left light. So next time they can convey both, whether they are coming for a war and from which direction they are coming from. So this zeros and ones, either on or off, can convey. Now it is conveying two messages. One is whether they are coming for a war, and which direction they are coming from. So for sure, a 0 and 1 can be a language. Okay. Okay, we will we came to know that's why we call it as binary, because there is no only two alphabets. Oh, okay. So that's why we call by. and this is called binary language, and this is the language only our computer can understand. Okay, so we need to know the hardwares. If we need to know the hardwares completely, we need to know the fundamentals, and after knowing the fundamentals, we will learn how AI is working along with the hardwares. Okay, so next is, what is serial and parallel communication? Okay, so in embedded systems, we will work with microcontrollers. Okay, first we need to learn what is a microcontroller and what is a microprocessor. So microprocessor, we know it is a processing unit of our any system, and microcontroller is nothing but a microprocessor. So microcontroller is nothing but a microprocessor. It's nothing but a microprocessor, along with some IO ports, along with some memory. So this is what we call it as a microcontroller. So microcontroller is nothing but a microprocessor along with some IO ports and along with some memory. Okay. So what is a microprocessor? What it will do? A microprocessor is the processing unit of our OS. So this microprocessor have some components. Okay, so it like our brain has some components inside it, like our human body has a brain. For our computer, microprocessor is the brain. It is a processing unit of our computer. Okay, since we need to learn about microprocessor, I am just showing some slides which microprocessor consists of. This microprocessor has instruction decoder in it, ALU in it, a data bus, address bus, timer and counter, registers, and a clock generator. So these in our human anatomy, our brain is the processing unit. Okay, inside our brain we have multiple components inside it, multiple organs inside it. Like like human anatomy, in in uh, uh, in general purpose operating system, we have microprocessor. In this microprocessor, we have some organs like this: instruction decoder, ALU, data bus, address bus, timer and counter, registers, and clock generator. Okay, let us consider a scenario where a mom tells his son to do some work. Let her tell her son to turn off the light or turn on the light when the evening comes. So when the 6 p.m. happens, the we will get the evening, and he has to turn on the light. So in order to decode this uh, instruction given by his mom, he should have a brain. So this fellow has a have a brain. So in order to know the timings, he should know some timings. He should know how to read the clock, and he should know some basic max. Okay, so this our brain should have a basic mathematical calculation. It should know some mathematical calculation. It should know how to calculate time, and it should have some memory. Because if we don't have memory, if the mom tells this instruction at the morning, if the evening comes, if he doesn't have memory, he will forget the instruction, and he will miss out it. So there is we need memory to store the instruction for the later purpose. Okay, so this microprocessor has an instruction decoder. In order to decode the instruction, what instruction our it is we are telling to the microprocessor. This microprocessor has a ALU because it has to do basic maths. Okay, this ALU will do the math, will do the logical operations for this microprocessor. This data bus and address bus. What is this data bus and address bus? Why we call it as bus? Just in reality, we use bus for the transport. Okay, from if I want to go from Chennai to my hometown, I usually take a bus. So bus is used to used for a transport. Okay, if in similarly in hardware, if we want to transfer as data from one component to another component, we use data bus. If it is used to transfer data from one component to another, we use data bus. Data bus is nothing but a wires. Address bus, if we use to transfer address from one component to another, or if we want to send address of the memory, okay, to the accumulator or to the latch, we will use address bus. What is timer and counter? Timer is used to count the internal clock pulses of the uh, microprocessor, and counter is used to count the external clock pulses. And what is registers? Registers are a special memories. In the using registers, we can control this hardwares. Okay, I will show you how to control hardwares using these registers. And what is clock generator? Since our hardwares work with different speed or with different frequencies, our hardwares will work. Everyone cannot work at the same data rate or at the same rate. So this clock generator will separate or or will segregate or will give the specific frequency which is necessary for that component. Okay. Okay, then we will come to know about serial and parallel communication. Okay, so let us consider. Okay, so let us consider an hardware. Let it be memory. Let it be ALU. And another hardware which is memory. Let us consider another hardware as memory. So we have two hardwares. One is ALU and memory. Okay, this ALU wants to send some data to the memory. Let it be 5. Okay, this ALU will send this data to the memory. But since our microprocessor is a digital microprocessor, this 5 will be converted into binary. So this 5 is in 8 bit. It is 0000 and 0101. So this is 8 bit of 5. If this ALU want to transfer this data from ALU to my memory, we have only this one wire. Using this wire, it has to send the data. Let us consider for sending this one bit, it will take 1 second. First, it will send 0 from here 0 to here 0. Then it will send this 0. Then it will send this 0 and so on. So it will take totally 8 seconds to send this data from ALU. This ALU take 8 seconds to send this data to memory. Consider another scenario where we have 8 wires between ALU and memory. So now you can guess what is going to happen now. So now this ALU will send the same 5 to this memory. Instead of sending one by one, it is going to send parallelly 0000 and 0101. So it will send every bit at once. Now in order to send this 8-bit data, it will take only 1 second. Previously it took 8 seconds, now it is taking only 1 second. Okay, now we have achieved a higher performance microprocessor by interconnecting the hardwares inside a microprocessor by parallel communication or parallel wires. I think you guys got the concept. Since we have increased the number of wires between the components, the rate of sending the data increases. Okay, so before I had only one wire between ALU and memory. Since it is sending bit by bit, it is called serial. So it is serial communication between the ALU and the memory. If it is sending parallelly, like 8-bit at once, or if it has 16 wires between them, let us consider it is having 16 wires between them, then it can send 16-bit data at once. In a single pass, it can send 16-bit data. So this is called parallel communication. So in order to know the embedded systems and we need to learn the serial and parallel communication. So this is called parallel communication. So obviously parallel communication is higher in performance. Serial communication is comparatively low in performance. This parallel communication is complex to design because we need to etch away some copper lines in the PCB or in the chip, and it is a complex to design this parallel communication. In serial it is not like that. It's very easy to design, and it consumes less space, and parallel consumes more space, and also parallel communication is costlier comparing to serial. So where we use parallel and where we use serial? Okay, inside the microprocessor, because it is a performance dependent, we have to use parallel communication inside microprocessor and inside a chip. So inside chip, every components or every hardwares are connected via parallel communication. So outside of that chip, we use serial communication. Like I'm using my mouse now to draw something over here. This mouse is connected to my laptop using a wire, USB wire. This USB wire uses some protocols, and this protocol uses serial communication. Like we use Arduino to program. Okay, we use laptop to program our Arduino, and uh, in order to dump my codes or my program inside this microcontroller or my Arduino, we use a USB wires. That USB wire uses serial communication. That means we use only one wire for data transmission. Okay, so this 16 wires, instead of calling it as 16 wires, let us go as some professional terms like 16-bit data bus. In professional way, we call it as not 16 wires or 8 wires, we call it as 16-bit data bus because it is transferring 16-bit at a pass. I think you guys got the basic idea of what is serial communication and parallel communication. So this is what we call in I think in my computer we have properties. There it will tell 64-bit operating system. You can say x64 based processor. This means inside my chip, every components are connected parallelly via 64 wires or 64 data bus. Okay, so it can send us at 64-bit data at a single pass. So it is comparatively higher performance computer. I likewise 32-bit. In now we are watching this live session, so you can search your computer. What is your computer? 32-bit or 64-bit? It's nothing but the data bus between the components. Okay, 32-bit is less performance, and 64-bit is a high performance, obviously. Okay, so we came to know about what is serial and parallel communication. Next, what are the types of serial communication? Since we are using in outside environment apart from the chip, we use serial communications. Okay, what are the serial communications we use? We use UART, we use SPI, and we use I2C. What is UART? It's an I will just tell the full form. We are not going to deep dive into these concepts. UART is nothing but universal asynchronous receiver transmitter. SPS is nothing but serial peripheral interface, and I2C is inter-integrated communication, inter-integrated circuit. I think. I'm sorry if I'm wrong. Okay, so these are some standards of communication. Like we in Tamil we have some grammars and we have some standard, and in English we have some grammars, and if we change the grammar, it is not meaningless, na. So likewise, we have some grammars, we have some languages for this Arduinos or for this microprocessor to speak with another component or another hardware. Even our Arduino can speak with another Arduino using any of these three languages. I used to call it as languages in order to make it simple. Okay, like I know some languages like English or Tamil or the Kannada or the Hindi. Like I know four languages. This my Arduino or my Raspberry Pi or my ESP32 all know these three languages. Since my Kannada friend knows only Kannada, I can speak with only Kannada with him. Since my Tamil friend know only Tamil, if at all he knows some English and Kannada, I can speak with him comfortably with Kannada or Hindi or in English. If at all he knows only Tamil, I should speak only in Tamil in order to in order to transfer, in order to communicate in order to send my data. Okay. So likewise, some components, some devices, the manufacturer they design with some specific protocol, communication protocol. For example, I have some SD card adapter module. That SD card adapter module knows only SPI communication. It doesn't know UART or I2C. If at all I want to speak with, if at all I want to communicate with that SD card module, my Arduino should speak with this SPI, because both need to speak with the same language. Okay, these three languages comes under serial communication. That means they use only one wire in order to transfer data between them. Okay, so we know what is serial and what is parallel communication, and we came to know about uh, what is a binary language, how it is work. We know what is analog and digital binary language. Okay, then we know about what is microprocessor. Okay. And inside microprocessor we have these things, we have these hardware, and it acts like a brain, it acts like a human brain, and it will work as a brain. Okay, since that mom given some instruction to his boy in order to turn off this light, that instruction has to be stored inside a memory. So that fellow has some memory. Okay, so as for an embedded engineer, for an embedded engineer, we that engineer needs to have some basic knowledge on memory, because embedded engineers, they have a challenge to deal with less memory. Okay, so in order to deal with memory, we should know some memory, what are the memory we have. Then after memory, we learn about the architecture, and after architecture we will learn about how to control some LEDs, and after that we will learn how to embed a in that hardware and how this will work uh, accordingly. Okay, let me open new file. Okay, so in memory so we have two memories like RAM and ROM. So in most of the interviews they will ask in embedded system, if you are going for embedded systems, they will ask what is the difference between RAM and what is the difference between ROM. So we should know about what is RAM and ROM. And people usually tell RAM is nothing but random access memory. So RAM is nothing but random access memory. Sorry about my spelling mistake. And if people usually tell what is ROM, so ROM is nothing but read only memory. Okay. So what is random access memory? If the interviewer asks what is random access memory, we will tell it as it is a temporary memory. It is used to store temporary data. And what is read only memory? It will they usually tell read only memory we cannot modify it. It is a permanent data. We cannot modify it like this. We used to tell. No, it is not like that. So consider we have this is a memory cell, and we have some memory cells inside. This is a memory unit, and we have some cells inside it. Let it be one, two. Like in a hostel, in a PG, we have PG every room numbers. These memories have some address. Let it be 1, 2, 5, 4, 5, 6, 7, 8. And in every memory cell, we can store either 0 or 1. Let it be X. I don't want to specify. Let it be X. So in every memory cell, we have some data, either 0 or 1. Okay. So if I want to read this fourth memory cell, what this fourth memory cell is having inside it, I can directly read randomly. I can access this randomly because before random access memory, we had sequential access memory. So before random access memory, we had sequential access memory. So what is sequential access memory? So like this random access memory, let us consider a memory unit. In that memory unit, we have some memory cells named 1, 2, 3, 4, 5, 6, 7, and 8. Okay. In this eighth memory cell, I have some data. Either it can be either 0 or 1. If I want to access this data, what I have to do is I have to travel through 1, 2, 3, 4, 5, 6, 7, and I should reach 8 after traveling all these memory cells. And after traveling all this memory cell, I will reach eighth memory unit, eighth memory cell, and we can access the data, read the data, and we can write the data. So if I take 1 second to pass over this first memory cell, I need 8 seconds, 8 seconds in order to read this memory, in order to read this data. What a pathetic situation. This is a very low performance memory. Okay, this is called sequential access memory, and we are not using it. We usually call it as SAM, not RAM. We usually call it as SAM. After SAM, there came the advancement that is called RAM. Okay. Now we don't have the worry of going through 1, 2, 3, 4. We can directly access 4, and I can directly access 8, and I can directly access 6. I can directly access anything, any memory cells, and it will take only 1 second to access it. It can be anything, or 1 microsecond or 1 second. I'm just giving for an example. So it will take same amount of time or equal amount of time to access any cell. So it is called as random access memory. Okay, so since random access memory came into existence, now we are not using sequential access memory. So that's how came this name random access. That's how the name came random access. You can randomly access any part of the memory cell or memory unit randomly, and it will take the same amount of time, and it is a bigger advantage for us. This random access memory have two subparts in it. So RAM have two subparts in it. What are they? RAM have two category in it. One is DRAM, another one is SRAM. In Arduino or in ESP32, in any controller, we use SRAM. We use SRAM in our ESP32 controller or in Arduino microcontroller, and even in some higher end microcontrollers, 32-bit microcontrollers or 64-bit microcontrollers, we use SRAM only. And we also have DRAM, dynamic RAM, and the full form of DRAM is dynamic RAM, and full form is SRAM is static RAM. Static RAM, and this is called dynamic RAM. Why it is called dynamic RAM and why it is called static RAM, and why we use static RAM in our microcontrollers? So in order to know that, we should know how this dynamic RAM and SRAM works. Okay, we can easily we can know it is it's a simple concept. This dynamic RAM, how it stores the memory means it has a transistor. Let it be a transistor. This is transistor. It has a transistor and it has a capacitor which is grounded. So if it wants to, it is this memory cell wants to store one one in it. It will store some voltage in this capacitor. Okay, if there is a voltage in this capacitor, it is called as 1. If it is not there, it is called 0. Okay, as of now it's stored, it has a voltage, maybe it's maybe a micro maybe in the micro level, or it may be in the nano level. Let it has a voltage. If it has a voltage, it is called 1. Okay, if it is not having, it is called 0. But when the time goes, this capacitor leaks. It will leak this voltage, and it will due in the due course it will lose its voltage, and it will become 0. Automatically it will become 0 because the capacitor cannot hold the voltage continuously. So we have a disadvantage here because it is not storing the data permanently. It is storing data for a short period of time. It is 64 nanoseconds, nano or microseconds. Please refer it on the online. For 64 microseconds, it can store that one. So we need and we are in a compulsion to store this data forever. How we can store it? The thing here we use here is we have some algorithms, or we have some structures that will, what it will do is it will read this capacitor for every 64 microseconds, and it will write whatever the data inside it. Okay, if it reads that this capacitor has one, and that is if the capacitor has voltage in it, for every 64 microseconds, this algorithm or this component will read it, and it will write inside in the capacitor. If it has a 0, it will read it and it will not write it. So we are in a compulsion to dynamically work in this, RAM, in this memory cell. So it is called dynamic RAM. I think you got the point. We have to dynamically work on it. No, but it is not the same case for this static RAM. Here we have some 6 transistors looped. Okay, here we have some 6 transistors looped inside themselves. and it can store this 0 or 1 inside this permanently. There is no compulsion for this extra component to read and write for every 64 microseconds. So okay, so we call it a static RAM. For example, how this 6 transistor store this data? I will give you an example. This is a NOT gate. I think this is a NOT gate. If we give 0 here, it will give 1 here. And we am giving a feedback to this NOT gate here. This one I'm giving it as a feedback. This one will come here and it will give a 0 here. Correct? So this will be in a loop, and if we go and read here, it will give 1, and if we go read here, it will give 0. So while by giving a feedback to another NOT gate, we are storing a data either 1 or 0, and if we go from this side, we will get 1, and if we go from this side, we will get 0, and we can store data like this. So likewise, like this example, they are using this 6 transistor in loop to store the data. Okay, so here this 6 transistor is higher in performance. We can read and write very fast, high performance. We can read and write very fast. So we are using this in a real time operating systems and real time systems, embedded systems. So our Arduino and our SRAM, sorry, and our ESP32 and STM32, everything has this SRAM. For example, in our Arduino, we have 2 KB of static RAM. To store the temporary data, we have 2 KB of static RAM. And where we use dynamic RAM, if you see this, observe this clearly, we have 6 transistors, and these 6 transistors will take much space. And this is complex in design, and it's costlier too, because we are using 6 transistor, and this dynamic RAM composed of only one transistor and one capacitor. This is less complex in design. Okay, this is less complex in design, and less, it takes less space. So it is less, it is why, since it is taking less space, it can store much data, much higher data capacity. Okay, clear? So since it can store much higher capacity data, we are using this DRAM in our mobile phones. In my mobile phone, I have 8 GB RAM, I think. 8 GB data, sorry, 8 GB RAM we have, 6 GB RAM we have. So this RAM and all, it is a dynamic RAM. It is nothing but dynamic RAM, because this static RAM will take much space, and it is a complex in design, and it's much costlier too. But this dynamic RAM is much cheaper compared with SRAM. Okay, okay. Then, so I think we are very clear about what is RAM and what are the types of RAM. And then what is ROM? I'll go fast because I'm running out of time. Then what is ROM? ROM, we call it as read-only memory. It is read-only memory. Why we need ROM? Because in the earlier times, once the program is embedded in a chip, it cannot be changed. Once the instructions are embedded in a chip, it cannot be changed. It is a it is a it cannot be changed. So it is called read-only memory. We can only read it. We cannot erase it. Okay, we cannot erase and write it. We can only read it. But that becomes a big uncomfortable situation for us. We cannot keep on reading, and we cannot keep on using the same instruction forever. So then came PROM. PROM, that is called programmable read-only memory. It is called programmable read-only memory. We can program only one time after the manufacturer gives us the chip. That also becomes a big disadvantage because the kind that the technology keep on evolving and we cannot stay back with the same program. Then came EEPROM. It is called erasable programmable read-only memory. This we can erase for a certain amount of times using UV light. Using UV light, we can erase this ROM and we can keep on program. Okay. Since I have to go for UV light for every time, I cannot go for every time. I cannot go and get UV light for every time to do erase and write. Okay. So I am going. Then came EEPROM. This is electrically erasable read-only memory. We use UV light to erase and write data in EEPROM, but we use this electricity or some low voltage electricity to erase and rewrite EEPROM, electrically erasable. That's why we call EEPROM. In Arduino, we use EEPROM. How much we use? We use 1 KB of EEPROM. Got it? And in ESP32 also we use EEPROM. It stores permanent data. Unless and until I erase the data, it will stay permanently inside it. And how much time I can erase and rewrite, since it is an erasable EEPROM, how much time I can erase and rewrite? So according to some resources, they are telling 1 lakh times. So 1 lakh times I can erase and rewrite this EEPROM. Okay. Then how much I can write and how much bit I can write and how much bit I can erase. So at a single pass I can erase 1 byte at a time. I can erase and I can write 1 byte at a time. So I can erase and write 1 byte at a time. Okay. If I want to erase and write 128 bytes, I should uh, I should do 128 times to erase and write it. So that becomes a big disadvantage, and it is a discomfortable situation for us. Then came the advancement and new technology called flash. Then came flash. Why it is called as flash? It's a brother of let us call it is a brother of EEPROM, and in this flash can erase and write 128 byte at a time. Okay, so 128 byte at a time I can erase and rewrite. So this can in a flash of second it can erase and rewrite. So we call it as flash. In Arduino we have 32 KB of flash. 32 KB of flash memory to store the instructions. Okay, to store the instructions we use flash. Then why we need EEPROM? Why we need EEPROM? To store the configuration data. To store the configuration data, we need EEPROM. To store the instructions, we need flash. What is config data? For example, I will take uh, in my program, my Arduino. I have programmed my Arduino to turn on the fan, to turn on the blower if the temperature goes beyond 32 degrees Celsius. So it is a summer time. So I am putting it as 32 degrees Celsius. So if the Arduino looks for the temperature for every 1 microsecond or 1 millisecond, and if the temperature goes beyond 32 degrees Celsius, it will turn on the fan. But my friend takes the same Arduino and is changing the 32 degrees Celsius to 25 degrees Celsius. So he wants to sit in a cool room. So he is changing the temperature to 20 to lower degree to 25. So these data are config data. This will this will change frequently when compared to instructions. And these config data are low size or lesser in size compared to instructions. Okay, this config data may be 1 byte or maybe 2 byte. This flash can read or erase and write 128 byte at a time. So in order to erase and write 1 byte, I need to erase 128 byte for every 128 byte at a pass, and I will read every other 127 byte, and I will write every 127 byte as it is, and I will rewrite this 1 byte. So it's a waste of time and it's a waste of resource. So I will use this EEPROM for the configuration data, and I will use this configuration to erase and write this configuration data. I will use this EEPROM. But these instructions, if the temperature goes beyond this some values, you have to turn the fan. These instructions are permanent. It will not change regularly or often. So we use these instructions inside our flash. Okay, because this flash can take only 10,000 times. It can take only 10,000 times. We can erase only 10,000 times. Beyond that, if we erase it, it will corrupt. Our flash will not work further anymore. Got it? So this EEPROM we can erase 1 lakh times, and this flash we can erase 1,000 10,000 times. So according to our requirement, we use this flash and EEPROM in our Arduino or ESP32 or in every other microcontroller. Okay. Okay. So we since the embedded engineers are very good at memory, we need to learn some memory. So I think we came to know about memory. And the last and final thing, we need just to give a clarification of RAM and ROM. RAM is used to store temporary data. If the power supply is not there, RAM cannot rewrite it. RAM cannot read and rewrite it, so we lose the data which is stored in RAM. But ROM is not like that. We use floating pin transistor technology. There it can store data permanently, even uh, if the power supply is not there. So in order to differentiate between RAM and ROM, I used to portray say a simple story. Let us consider say a government employee. This fellow has a table before him. This fellow has a table before him. This is the government employee. Okay. In this table, he has some files. Also, he has given some wardrobes, some shelves to keep some files inside that, and he can keep some files here also. Let us consider he is having 100 files. He is having 100 files. Then he will keep some important files here and uh, some non-frequent files here. Am I right? So if we consider 20 important files, that is keep on we have to keep on see that, and we should keep on refer that every day. He will keep that 20 files in this disk, and the non frequent files he will keep here. Rest of the 80. So this ROM is bigger in size. This is I call this as ROM. This shelf as ROM. This is bigger in size, and we cannot change. We cannot refer this frequently. This RAM is smaller in size, but we use that frequently. Okay, understood? We use that frequent data. We have frequent files we keep here because for fast access. This RAM we can access very fast compared to ROM, because this disk is in front of him, so you can access these files very fast. So this is we can this can be an complete analogy of RAM and ROM. This disk can be considered as RAM, and this wardrobe can be considered as ROM. If he want to take some files which is in ROM, he has to go there, and he has to take some files from there, and he will read and he will keep there and come. So it will take some long duration for this access of ROM. For this access of RAM, it will take only small amount of time. Okay, that's why we have, if we have more RAM, we can store more files here, and we can access this very fast. Okay, so RAM and ROM we have finished. I, I will go fast. Next, architecture. What is architecture? You might have heard about ARM architecture, AVR architecture. What are those? Okay, so what is an architecture? We usually know that we have a profession called architect. We have a profession called architect. All they will do, they will plan they will plan how to construct a building, and then where to go, the pillars has to go where, the drainage has to go where. So they will design the complete plan of the building, or of the city, or of the drainage system. So they will design which components has to go where. Okay, likewise we have AVR architecture for Arduino, and we have ARM architecture. In ARM based microcontroller like LPC, I think 2768. Uh, so that LPC and all, we have ARM architecture microcontroller. How this architecture plays a major role in performance? This Arduino cannot be compared with ARM architecture because it is an AVR architecture. Now we can understand this architecture in a simple way. I will explain you that one. Let me have a kitchen here. This is my stove. This is my stove. This is my kitchen, and I have a sink here, and I have some shelf here, and I store some curry leaves, some sugar, salt, milk, and I have some refrigerator here, like this, beside me itself. Okay, so these are the components inside the kitchen. So these are the components inside my kitchen. Okay, so say consider I am cooking here. If I want to put a tea for myself, I should take the milk from the refrigerator, and I should take some utensils from my utensils cupboard, and I should take some sugar from this shelf, and I should take some other ingredients from the shelf, and I will put it in the stove, and I will do the cooking. Okay, so these are the components, and these are components are designed in such a way that I can access these components in a period of time. Okay, if at all I want to get milk from this refrigerator, I take some time to get it from the freezer, and it will take some time to put it inside a utensil, and it will take some time to cook, and it will take some time to clean the utensil also in the sink. Okay, so if you let me portray another kitchen. Let me consider this kitchen, and I have a fridge here. I have this stove here, and I have this utensil keeping box here. I have some ingredients shelf here. I have dishwashing place here. This is where I can wash my dish, and I am standing here. And this design, this layout is very difficult for me, and it will take more time to do the same cooking. To put the same tea, it will take more time, because it is a, see, the fridge is here. I should take milk from here, and from here I should come here and put it in the stove, and again I should go to take some ingredients from here to here, and from here to here to take some utensils from here to here, at last to wash the utensil. So this design is very bad. This design is very good. Comparatively it is good, because I can do this tea in maybe in 5 minutes. Here, it will take 10 minutes to do the same, to prepare the same tea. So this design and components, it may be because some that this shelf also, we have modular shelves, and it can we can easily access ingredients in the shelf. So we have modular kitchen like that. So these components plays a important role in performance. In order to put the tea within 10 minutes, these components has to this will play a important performance. Am I right? Okay. This design, this architecture plays an important performance. Okay. So this architecture and these components plays an important role in performance. I think this kitchen has a better performance, and here I can prepare a tea very fast compared to this. So I can call this architecture as a good architecture. Okay. So according to architecture, with respect to architecture, the performance will increase or decrease. Our ARM architecture is high performance architecture. It is a CPU architecture. There they have designed, they have kept timers, and those timers have some specific advanced timers we have, and uh, we have counters, we have registers, likewise we have instruction decoders, likewise we have ALU. So these are all some, like we have modular kitchen. They are advanced hardwares, and they are designed in a way they can access quickly. Okay. So in order to okay, I think you guys came to know about what is architecture and how uh, architecture plays an important role in performance. Okay. Obviously, this ARM architecture is very fast, and it's a very lightweight architecture. And the instruction we use here is risk architecture, risk instruction set. Okay, reduced information set instruction. But in our in my laptop, which I'm online today, then this laptop uses CISC instruction set, complex instruction set architect set computer. Okay, okay. Mm. My okay, my LPC 27680 is a risk based computer set, and next we'll go to the uh, coding part. So I'm opening my Proteus. So I'm opening a new project. Okay, so I'm going to pick an Arduino here. Okay, okay, and you can see I already told you a microcontroller is nothing but a microprocessor with some IO ports and memory. Okay, so these are the IO ports, and we have memory. Like I already said, we have flash of 32 KB here. Okay, so we will store our instruction inside that flash, and we use these IO ports in order to connect some sensors, because this we want to control outer environment. If we want to read the outer environment data, we need some these IO ports. Through these IO ports, we will connect some sensors. Those sensors acts like an like we have eyes, ears, nose, like receptory organs. Those sensors will act like that. Specific for temperature, we have a specific sensor for the sound to detect the sound. We have a specific sensor for to detect IR waves. Okay, infrared radiation. So like that, we have some many number of sensors. Okay, this sensor will get the outer environment data, and it will give it to the micro. this small microcontroller. This chip is Atmega 328P, and this chip is manufactured by Atmel. Okay, since it is working in the 16 megahertz frequency, it is called Mega. Since it is having a 32-bit flash memory, it is called 32 here. 32. Since it is an 8-bit microcontroller, that is, these hardwares are connected uh, between them by 8-bit data bus. Okay, so that is called, we will call it as 8-bit. And it is called as pico power. It doesn't consume much power. So now I'm going to take some sensor here. After this, I will embed some AI in Raspberry Pi, and I'll teach you. Instead of IR, first of all, I will use LED. Okay, I'm connecting this LED to 7th pin and to ground. Okay, so in order to turn on this LED, I need to give instruction to this microcontroller. This microcontroller now acts as a brain, and it has some IO ports because we have legs and hands. We can switch on the light by our hands. We can go to near the switchboard. We can turn on the light, but this cannot do. So that only we have IO ports. Okay, in order to give some hands and like we have hands and legs, we have to give some actuators in this IO ports. Okay, so we now code for this. So now I'm using Arduino programming, not embedded programming. Um, since I have connected this LED to 7th pin, I'm telling my microcontroller that I have connected 7th pin output device. I have connected an output device in the 7th pin. I want this 7th pin, this LED, to glow and off for every 1 second. So digital write. What is digital write? What is digital? Digital means it's a discrete set of value. This Arduino can give voltage to this pin, or it cannot give. It can do either one. It can be either high means it will give voltage to it. If it is low, it will not give it. So digital write 7th pin comma high means it will give some high voltage, not high voltage, it will give 5 volts to it. And I'm giving some delay, don't do anything for 1000 milliseconds. And I'm telling it to not to give, so I'm giving it as low. So this will give 5 volts for 1 second, and it will not give 5 volts for another 1 second. So we can infer that LED is blinking for every 1 second. So now I'm uploading this sketch to my Proteus. First I'm saving this desktop. So after this I'm going to export this. Okay, now I'm going to my Proteus, and I'll double click this microcontroller, and I'll check for my code FTP will. So here it is there. This X file I'm uploading this one. Now I'm playing this one. You can see this LED is glowing for every 1 second. We have given the instruction to this guy, to this Atmega 328P, and this fellow is executing that instruction. Okay, we have connected an LED to this IO port. Since we have IO port and memory in this small PCB. It is called as microcontroller. Okay. Okay. Next, now I have written. This is an Arduino programming. This is very easy to do, but we need to know embedded programming. We need to know AVR architecture. In AVR architecture, they if we go to, you can go and see the manual in the online, the instruction set manual. Okay, we need to know the architecture in order to control those hardwares inside that microcontroller. Okay, in AVR architecture, we have three registers. Like we said, we have registers. We have three registers. They are DDRD. We have many registers. These are the primary register DDRD. We have port register, and we have pin register. Okay, so we have three registers. This register is used to control the pins, because I have given uh, this pin as output pin. Since I have connected an output device here, I have to mention that I have a connected output device there. So DDRD is used to tell the microcontroller that whether I have connected an output device or an input device in the IO port. This port pin, this port register is used to control the voltage in that pin. If this port register is high, this will give high 5 volts to it. If the port register is low, it will give no voltage to it. So this we can control this same LED using that. This pin register is used to read whether that pin is giving whether let me connect an sensor here. If I connect a sensor in this A0, this sensor will give some data to it, to that A0. In order to, for example, in order to read this A0, I need this pin register. I need this pin register. Then I can, if I read this pin register, I can know whether this sensor is giving some data or not. So in order to read some IO port, I need this pin register. In order to control the IO port, I need port register. In order to say whether I have connected an output device or input device, I need DDRD register, data direction register. This is DDR register. DDRD, not DDR register, data direction register. Okay. Okay. So now, since short of time, I'm unable to do that. So how we use AI in this, because we can we now we can able to uh, control this microcontroller using some code, some C++ or Python, and that code is written by us, and in order to control control that microcontroller using AI, we need to know about some basic configuration of Raspberry Pi, because this Arduino and ESP32 cannot hold an AI software inside it, because we don't have that much memory inside it. In Raspberry Pi, we have a sufficient memory space. We can dump our AI inside it, and we can do some cool stuffs inside it. Okay, so I have did some work here previously. I will open it. I think so. I'm going to my Visual Studio and open my folder. Um, there I have documents. In documents, I have Python 3.6. So using AI, for AI we use some sensors, and the main primary sensor we use for AI is camera. Using the camera, we can process the image, and we can and also we have lidar. This lidar using augmented reality, and uh, it can self drive, since Tesla's use lidar for self driving cars. So we can do many cool stuffs. And what we have done is, in a for a second, I will open that one. Open folder. So here I will show some of the cool projects. I think where I did. Okay. So here I have a program. So this program I have embedded this one in a Raspberry Pi, and this what this will do is it will open my webcam, and it will check for the specific color which I have given here. Okay, using this trackbar which I have given here, it will try check for the specific color, and it will show that specific color, and it will track that specific color using OpenCV. And this cannot be done in Arduino or ESP32. This can be only done in Raspberry Pi. Okay, let me since this will work in my lab itself, I will do it. um, Let me check the code once. Okay, lower bound, upper bound. Okay, it is. Oh, my mask is not opening. Mask resized. Okay. So in order to detect this yellow color, I am you can see this frame is moving here and there because this is detecting this yellow color. Oh, let me do it very precisely. Let me do it very precisely. Please stay on the line. Um, in HSV, we can see we can check for the yellow color. For the yellow color, so 0 to 90. So we have the between this is letter this is not 90, this is 45. So between 0 and 45 we have yellow here. Okay, so let me track yellow. So between 0 and 45 so you can see முடிவு முடிவு. So you can see this I can make this I can make my um, program to only detect this object. You can see this is moving, my frame is moving while I'm moving this object. So you can do some cool stuffs like this using OpenCV. So I can embed this OpenCV inside my microcontroller, and we can do some cool stuff. And we have also done some projects related to embedding some AI software inside our Raspberry Pi. Uh, this like um, YOLO and some other with some neural networks. We have embedded some AI in our microcontroller, like we did to detect some fire. And if the fire is detected using AI, if the fire is detected, to open the valve of the fire extinguisher. Okay, to detect some monkeys or to detect some harmful snakes or harmful organisms. Okay, using AI, we can do some cool stuffs like this, and um, we can make to work our microcontroller in our requirement. Okay, if the fire is detected, to open the nozzle of the fire extinguisher and to douse out the fire. If it detects some monkey, it will do some alarm thing, and it will make the monkey to move away. If it is uh, detecting some snakes, because these are not possible by our normal embedded programming. These are possible only with the help of AI. Okay, so using AI, we can detect some, using camera, we can detect some harmful snakes or harmful things, and according to our requirements, the distance. So self-driving cars. So these and all possible only with AI. So these embedded engineers are now in a compulsion to learn AI, and they are in a compulsion to learn embed AI in their microcontrollers. Okay, okay. So thanks for joining here in a short span of time. I think I have completed most of the fundamental things, and I have rushed the some AI parts, AI things. Let me, if I get another opportunity, let me explain in a detailed way, and let me show my hardware components, and I will show the projects what we have done. Okay, so thanks for joining, I'm also very glad for this FTP uh, session. Thanks for joining. Thank you.